We are continuing our discussion in Chapter 3, Lesson 4, solving exponential and logarithmic equations. Okay, the next set of equations that we're going to look at are logarithmic functions, and we're going to use the one-to-one property of logarithmic functions. And it states, if log base b of x is equal to log base b of y, then x equals y. Now, an example of what this looks like. If we have two logs with the same base, then the expressions that follow those logs are equivalent to each other. So if I have log base 6 of x squared plus 5 equals log base 6 of 41, I can set x squared plus 5 equals to 41 and solve the equation for x. Okay, when you are ready, I'm going to have you turn to example number 3. And we're going to look at several types of equations that uses the one-to-one property of logarithmic functions. Okay, example 3. To solve each equation. Okay. When we are solving logarithmic equations, okay, we need to condense each side of the equation into single logarithms with the same base. Okay, condense each side of the equation into single logarithms with the same base. So number 11, we have log base 2 of 5 is equal to log base 2 10 minus log base 2 of x minus 4. I'm looking at the right side. I need to combine log base 210 minus log base 2x minus 4 as a single logarithm. And I'm going to do so using the quotient property that we learned in Chapter 3, Lesson 3. So we have log base 2 of 5 is equal to log base 2. I'm subtracting, so I'm going to combine those using division. 10 is my numerator, x minus 4 is my denominator. Now that each side of the equation is a single log, both with base 2, I can set the expressions 5 and 10 divided by x minus 4 equal to each other. Okay. I can turn 5 into a fraction by putting 5 over 1. Now I have a proportion and I can cross multiply. So I can take 5 times the quantity x minus 4, and 1 times 10 is 10. If I distribute, we have 5x minus 20 equal to 10. I can add 20 to both sides, so 5x is equal to 30. Divide both sides by 5, and x equals 6. In problem number 12, I have log base 5 of x squared plus x is equal to log base 5 of 20. Each side is already written as a single log, so there's nothing I have to combine together. Okay. Since both logs have the same base, I can set the quantities x squared plus x and 20 equal to each other. Okay. Because I have x to the second power, this is going to represent a quadratic equation. And anytime I solve a quadratic equation, the equation must be set equal to 0. So I'm going to subtract 20 from both sides. I have x squared plus x minus 20 equal to 0. Okay, and I'm going to factor. I'm looking for two numbers that multiply to make negative 20 and add up to a positive 1. That's a positive 5 and a negative 4. I will we'll finish by setting each quantity equal to 0. X plus 5 is equal to 0. X minus 4 is equal to 0. So I know that x is equal to negative 5 and x is equal to a positive 4. Okay, I'm going to have you attempt 13 and 14. So pause the video, attempt those two problems. When you're ready, press play, and I'll go through those to see if you got the answer correct. Okay, number 13, I already have those combined as a single log, so I'm going to set 2x equal to x squared minus x plus 2. And I have a quadratic equation, so I'm going to subtract 2x from both sides to set those equal to each other. I have 0 equals x squared minus 3x plus 2. Okay, I can factor. I'm looking for two numbers that multiply to make 2 and add up to negative 3. That's a negative 2 and a negative 1. Set each quantity equal to 0, and x is equal to a positive 2, and x is equal to a positive 1. Problem number 14. The left side is already written as a single log. Okay, the right side, I have two logs, both log base 12, and I am adding those together. So I'm going to use the product property to combine those as a single log with base 12. So I have log base 12. I'm going to multiply x times 4 to get 4x. Now that each side of the equation is a single log, both with base 12, I can set the expressions x plus 3 and 4x equal to each other. Subtract x from both sides. 3 is equal to 3x. Divide both sides by 3, and x is equal to 1. All right, we're going to stop here today with the 3.4 notes. We're just looking at examples 1, 2, and 3. Next, I'm going to have you move on to the homework. There's several problems out of the textbook. I want you to try those. Make sure you show all work, check your answers, and write down any questions you need for me to cover next class. Good luck.